Yes. So technically, these are the steps for the calculating the correlation coefficient. So what is that one? Start a new document by pressing Control N. All of you are okay? Right. Then next one is add list and spreadsheet. Right. Can you also follow this one? Can you hear me? Okay. Yeah. Yeah, you can hear me. Right. Yeah. So start new document and then add list spreadsheet. Enter the data one by one. Okay. And also you have to name these columns. Everyone is okay in naming these columns? If you don't know, tell me how to. I can show you how to do it. I mean, you have to just type it. Yes, you go there and type it. Right. Yeah. Having entered all the data, what you have to do is press Control I and select the calculator. And once you get the calculator, and then after that you have to go to the menu, statistics, stat calculations, linear regression, A plus Bx. Not the other one. A plus Bx is what you have to pick. I guess. The-
Control I.
Yeah, so having entered it, so you have to put Control I. Hmm. Oh,
Do I press data and stats?
yeah, then after that, you have to go to the stats, then stat calculation, linear regression.
It shows me a graph.
Graph? Yeah, that's on. Yeah, good. Then once you went to the linear regression, yeah, then you will show it will give you a graph. And then did you go to this one? Did you name the X and Y list? No. Then go to the menu, right? And then you have to sorry, when you press the linear regression, what will appear? You'll get this drop down selections. And then once you press it, you'll get the you have to name the X list and Y list. X list type income. I mean, you have to. I think you can drop down. Yes, income and Y list CO2. Yeah, you got that. Wonderful. So then once you got it, you then after that, what you have to do, press enter to exit pop-up screen. Did you get the these statistics? No? Then yeah. So after you went to linear regression, did you get this screen?
Linear regression didn't come up.
Linear regression didn't come up. Okay, so you went to this one in the stat calculations. Did you get the linear regression? This one? No? Oh, that means you haven't gone through a different pathway. Okay, that means, right, so you having entered everything and you name the headings, yes? Then you have to go to the statistic menu, statistics, stat calculation, linear regression, A plus BX.
Here it's just named aggression.
Then,
Regression.
yeah, linear regression, A plus BX.
I'll show linear A plus BX.
Yeah.
Do this.
No, not sure. So can you go back to this menu thing? Right. So once you're in there, yeah, regression. Yeah, linear, show linear, show. Okay. Show linear.
Is this filling out the calculator?
No. This is for your honors. Yeah.
Oh.
TI. Right. What is missing? Control I. Okay. Can you go back to the sonus? So we go back there, right? Then control I. Control I. Then select calculator. Right. So then the menu. We have to go to menu. From menu statistics. Yep. You follow me, yes? Statistics. And then stat calculations, first one. And then you go this one. In two. Okay, so you press that one, that plus Vx. Then you can drop down the let's see. Now you can pick up the items which are income. Then next one is Y list is what? CO2. Right, these are same thing. With those things we don't have to change. Right, and then we just press OK. Yeah. See, that same thing is getting, yeah. Then guys, Aken, you okay?
Yeah.
Yeah. Did you get the same answers? Okay.
Yeah.
Did you get the same answers
Pretty
as
sure
this one?
as which
Sorry?
one? Same answers as which one?
Same as this one.
Oh yeah.
This one.
Yeah, yeah.
Okay. Right. You okay, Eka?
Yeah.
Yeah. Now this is basically then when you get there, right? You will get the R value. What's the R value? R is the uh, correlation coefficient, right? Correlation coefficient. So which is 8.818. So if you round it 82, meaning what does that mean? So is it strong, moderate, weak, no association, positive, negative? What is it? The relationship, what are we checking now, guys? What did we entered? The income level of countries and CO emission, carbon dioxide emission, right? And then what can we say? We have got the R value as 0.82, meaning we have a strong, moderate, or negative what?
Moderate.
Moderate. Okay, what do you think?
Probably around moderate.
Sorry?
Moderate.
Can't hear. That's it?
Moderate.
Moderate? Both of you are saying moderate? No. Why not? It's strong. Why? See? Point 0.75. So where do we find 0.82? First one, yes. So that means what is it? It's a strong positive. Yeah. Yes. Hello. Right. Then guys, basically that's it. Then we have to do. So this one is in the textbook as well, the measuring relationships with different R values, right? So then, yeah, technically, yeah. So we'll go through this one. Classify the strength of each of the linear associations. R is 0.35. What would you say? If you want, you can take, I mean, you can take it down, otherwise it's in the textbook anyway, right? This is the list of everything, right? So classify the strength of each of the fun linear associations. I is
Moderate.
moderate, 0.35 means? No, moderate means what? 0.5 to 0.75, yes. So it's, what is it then? Weak, positive. Then B, how strong the relationship.
Strong negative.
Strong negative? No, this is not strong. Moderate. Why? See, this is the thing. Right? Then 0.992. What is that? That is strong, yes? Strong? Strong positive, yes. And D?
Moderate.
Moderate? No. Negative 0.159? Yeah, so that is this one. So what is it? No association, yes? Right. Okay, guys, then tell me the answer, work out this one for me, and then tell me the answers.
go to the table?
Yep.
Is A strong positive?
Strong positive. Yes. B.
No association.
No association. B. You sure?
I'm not sure.
Mm-hmm. Right. Okay. What do you say for B?
For which one? For B.
B.
D. I'd say
D.
it's what? B.
Yeah. Second one.
Okay, yeah, that's strong. Strong negative. Yeah.
Strong negative. Yes. Yeah. Strong negative. Correct. Ekam, what is C? Moderate. Again.
For C, yeah.
Yep.
That's weak.
That's
Positive weak.
weak.
Yeah.
Positive weak. You sure?
Yeah.
No. Is that positive weak? Sure. Look at this one.
No, okay.
What is it?
No association.
No association. Why? Because see, 0.224, yes? Where does a 0.224 falls? Here. Yeah, 0.224. That's in the no association zone. Right? C is no association. D, Ekam. You didn't do that one. You want to think about it?
Is it strong negative?
Strong negative. Okay.
I would say moderate
Moderate
negative.
negative. Yes, moderate negative. Why? 0.667. Where does it fall? Which one item? Yeah. You think it's moderate? Where does it fall? Negative 0.67.
Moderate.
Moderate, negative, yes. So basically it's coming here in between. So 0.67 we'll find in between them. Is it hard?
I don't understand it.
You don't understand it? Okay. So basically, we have to find when they have given us the R value. So see, R is 0.35. If it is 0.35, what do you think? Where does it fall? 0.35. In this one. 0.35 positive. Where does it fall? Moderate? 0.35? No. Is it that hard? 0.35. So you have, so basically what we will say is 0 to 1. Yes, let's say positive. If it is 0 to 1, what are the values we will find? We'll say 0.1, 0.2, 0.3, and so on. 0.6, 0.9, like that, we'll find this. So then 0.35, where do you find 0.35? Which is here, yes. If it is 0.35, where do you find it here in the table? Here. 0.35 is going to be weak, right? Next one. I is negative 0.507. Where do you find 507? Negative 507. 507. Yeah. Yeah. Negative 507. So it is going from negative 0.5 to negative 0.75. Right? And then what is the next one? 0.992. Where do you find that? Point 0.992. Strong positive, correct? The top one, it's here, yes. 0.9 you will find in between there. Negative 159. Where do you find negative 0.159? So basically you can say 16. Negative 0.16.
Weak negative.
Weak negative? No. 0.16. 0.16 you will find here. See, negative 0.25. So then negative 0.25 to positive 0.25. So you will find negative 0.16 somewhere here. Whether it is positive or negative doesn't matter. It will be regardless in there. Okay. Basically, if you are finding it hard, you know what you have to do? The only exercise is do the number line. You know number line? Yeah. So basically, you can put like, negative 1, 0, 1. And then technically, you can find the values. Right? So if it is, as I said, negative 0.1516, where do you find it? Somewhere here. So if you want, you can subdivide this one into parts. Right? You can say this one is 0.2 or 0.1, whichever, I don't mind. 0.1, but negative though. Right? These are negative. Negative 0.2, like that you can do. And see where it falls. And then in this case, this one will be 0.1, 0.2, 0.3, like that. It goes forward. But this side is positive. This side is positive, this side is negative. To your left, negative. Go to the right, positive. Okay. Then guys, right. Now this one. Correlation and causation. Right? Any of you have done this one at school or somewhere? Causation, the concept.
What in the topic?
Yes, the topic causation. Have you done this? Did you do this at school? Causation? No. Akin, have you done causation?
No.
Okay. All right. So causation is now first the correlation. What is correlation? Correlation is that we can see an association in between two numerical variables, because in this chapter with the scatter plot, what we are looking at is numerical variables. So the relationship between two numerical variables is what we call as correlation, and also we measure it with the correlation coefficient, which is R. Now causation means, guys, we are saying, look, causation is that there is a cause and effect incident. What is that? For now, for example, let's say um, uh, the same thing that we did, I think, the studying hours and um, score or the marks, right? So there can be a cause for the positive relationship between studying time and marks. Why? Because when a student makes an effort on the studies, of course, that person will have more experience and then more understanding, right? More insights. So then, as a result, can answer the questions in the exam. So then there is a cause and effect, right? So because there is um, um, studying time or working on it will increase the result, right? However, without such a cause, right? Without such a cause, also there can be a correlation. So basically, a correlation, right? Correlation, I mean, having a correlation doesn't mean that necessarily there is a cause and effect. I don't know if it makes sense. Does it make sense? So let's say there is a correlation. Now, for example, there is a famous thing. There is a strong positive correlation between number of IKEA stores in a country and the number of Nobel Prizes won in that country. Okay, so does that mean for us to get more Nobel Prizes, we need to increase the number of IKEA stores? No. I think in Melbourne we have only two or something. Yes, one or two, probably two, I think, in Melbourne. Right? In Victoria we have only two IKEA stores. So does that mean we need to increase the IKEA stores to get the uh, Nobel Prizes? No. So that means even without a cause and effect uh, incident, there can be a positive correlation or negative, whatever it is, correlation. There can be a correlation, strong correlation. It doesn't mean that there is necessarily a cause and effect. Okay. For example, another thing I can tell you, the the amount of or the number of people who are applying sunscreen and the number of people who are fainting. Is there a correlation? No, there is no correlation between sunscreen and the fainting, but there is a correlation like this. There is a cause, common cause. What is the common response? Or common cause is that why people apply sunscreen is on hot days when it is more sunny. When it is more sunny, of course, people can get fainted, right? So like that, there can be a common cause or some reason behind that. Rather than that, there is a strong correlation doesn't mean that necessarily there is a strong cause that is changing the variables. Does that make sense? Good. Right. Now see the example they have given. Okay. We have found, they have found, see, they have found high correlation between smoking and heart diseases. Do you agree with that? There can be a high incident of smoking rate and heart diseases. Yes, positive. I think definitely it should be strong positive. Now see, however, we cannot conclude from this correlation coefficient alone that smoking causes heart diseases. So that we can't say necessarily smoking is causing heart diseases straight away. Having found a strong positive relationship between these two variables. Right? That's the thing. Because that's what I was telling you. So like see, IKEA stores and Nobel Prizes, sunscreen and fainting. So like that there is a positive correlation or there is a strong correlation doesn't mean necessarily that it is causing. So now see, another possible explanation is that people who smoke neglect lifestyle factors such as exercise and diet. Because they are addicted to smoking, right? They are having a bad lifestyle so that they are missing their basically life, basically they are not healthy. So then what will happen? It can create a heart disease. So then have a look at this one, guys. Correct interpretation is that high correlation between smoking and heart disease would be those countries which have higher rates of smoking also tend to have a high incidence of heart disease. So what's the correct interpretation? What do you mean by interpretation? Explanation. So correct interpretation or the explanation is that people or the countries having high smoking rates would tend to have higher incidence of heart disease. So rather than that, we are not going to say, look, smoking is directly impacting heart diseases. Okay, I don't know. I mean, actually, I don't know if it is the case. I mean, I have seen, right? So when I go to the doctor, so doctor asks if you smoke, I say no. So then basically they would say, ah, look, then that means you'll have a small chance of having heart disease, so like that. Okay. However, then incorrect interpretation is that high correlation, smoking rate, incorrect interpretation is that smoking rate increases, then this one. Incorrect interpretation is that as the smoking rate increases, then heart diseases also will increase. Also incorrect would be to state reducing smoking rate would reduce the incidence of heart disease. Yeah, we can't say both ways. We can't say increasing smoking rate will create heart diseases, or we can't say that reducing smoking rate will reduce the heart diseases. Right. Any questions? Do you understand that concept? Good. Next one. Correlation and causation. Have a look at this one. Right. correlation coefficient between per capita income. What do you mean by per capita income? Don't know. Okay, do you know per capita income?
No.
No. Per capita means a Latin term. Latin, it's a dead language. Nobody uses in the world. Dead language, but it has a high influence on, especially on English. However, per capita. Per capita means per person. Income per person. In other words, if we take the total income in a country, let's say in Australia, assume how much they make in a year is 250 billion, right? And our population is how much? 25 or 27 million. Let's say 25 million, right? To be simple. Then this one will give us a receipt per the income per person, right? Income per person. So income per person is basically, excuse me, what we say, So then we are getting how much? 100,000. 25 goes into 10. No, 10,000, yes? Yeah. So whichever. So basically, this is what we will call as per person. So the income per person, right, is what we call as per capita income, right? Okay. Now, guys, so this one is saying per capita income and the carbon dioxide emissions in tons of 11 countries is equal to 0.8. Does this mean that reducing per capita income will result in decreased carbon dioxide emissions? What would you say? So we have found what's the relationship between these two variables, income per person's income and carbon dioxide emission is equal to 0.82. So strong positive, yes. This is strong positive. So does this mean that reducing per capita income would result in decreasing carbon dioxide emissions? No. So what we can say is what? We will say that countries with higher per capita income would tend to have, see, that's the word we are using is tend to have a higher carbon dioxide emission. It doesn't mean necessarily that, look, if you increase your carbon dioxide emissions, your income will increase. Or if you decrease it, your income will decrease. No, we are saying the countries with higher per capita income would have or would tend to have higher carbon dioxide emission. Okay, have a look at this one. This is interesting. Now try this 12. Yeah, this one. Yeah, I can help you. Right. Okay, what do you think about this?
There's not really a correlation.
Yeah, that will. So does that mean that taller people, taller people are better at mathematics?
No.
Yes. What
No.
do you think? So
Me
that
either.
means if you want to be good at maths, you have to grow tall. Yes. No. That means shorter people can't do maths. Yes. No. Then what does that mean? Has any possibility, any possible or common response for this one? Excuse me. Not sure. Right. So, do you get the question? So the question is, guys, right? If the heights and the scores obtained on a test of a mathematical ability, uh, by a group of primary school students in year prep to year 6 recorded, right? Year prep to, that one was recorded. Yes. Then then they have said strong correlation was found with the height and the yes height and the uh, um, marks or the score, right? So, what is the possibility, right? So, this one, the possibility is that um, yeah, the possibility is that this is definitely this is not causal, or this is not, there is no cause. Then what's the cause, guys? What's the common response? The common response is that because this is from year prep to year 6. So when they are year 6, so if you compare prep and year 6 people, then what do you think about their height? Definitely year 6 will be, people will be taller. Why? Because they are more age. They are actually, they have actually grown up. They are the more senior people in the school, in the primary school. So that means they will tend to have a better maths knowledge as well compared to prep and year 6. So then that means the people who are at year 6, who are senior relatively, will have a better maths knowledge as a result. That's why the combination has come. Taller people are better at maths. Not actually, to answer this one is, there is no cause. There is no cause, so that uh, there is no causation. There is no cause and effect here. Just there we can see a correlation or a relationship between these two variables. Not, this is a basically non-causal incident. There is no cause. Okay. Then guys, technically that's it for 7C. Then we can do some questions. Shall we, do you want to do a question, or shall we go through the theory? Shall we keep going on the theory? Theory, yeah? Okay. So we have to do 7D. Okay. 7 is about interpreting and predicting a linear model. Yeah. That's it. Okay. So basically, guys, I'll quickly do 7D and E. Right. 7D is actually, it is not hard. It's quite simple. Right. Fitting a linear model to the data. Right. Okay. Right. Now, a straight line has been fitted by eye. What do you mean by fitted by eye? When we are doing fitted by eye means we are not using a scientific method. As we see, we draw a line for the plot. So, however, there is a method to do it. The method is you need to have equal number of plots on either side. Okay. So now have a look at in this one. Can you see a equal number of um, uh, plots in either side? Yeah, almost. So I would say like on the uh, 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 I mean lower side of the line. So basically to the lower side, I can see two, right? Two of them are there, but on the top of that, we can see three. That's okay, right? So the point is that we need to have equal number of plots. That's what when you are doing it by eye, that means manually you are doing it. Okay, so then that's fine. Then they're asking what is the car velocity when time is 0. Velocity means what? I think the speed is the speed that moving velocity. I think I don't know. Velocity is a physics concept, I think. Right. So then, however, guys, let's say speed, meters per second, and then time is given. Then what is happening is as the time is increasing in seconds, the speed or the increase is also increasing, right? So when it is increasing, what happens is, right, we can plot it. So when we have plot it, they're asking what is the car's velocity when time is 0. When time is 0, so time is in the sense the y variable is 0. Sorry, this is y. X variable is 0. When x is 0, y value we are calculating. What do you call it? We give a special name for that. What is it? S starts with I. Intercept. Very good. This is the intercept. Right? Intercept means the place where the graph touches the y-axis when x equals 0. Wonderful. So then which we give in our equation also a plus bx. A is the intercept. Intercept in this case I would say around 18. Right? Then that's 18. And then we have to calculate what is the slope of the line. How do you calculate slope, guys? Slope of the line. Rise over run. Very good. What you have done in year 10 maths, year 9 and 10 maths, rise over run. So that is, if I do rise over run, basically, you have to pick two items. You want me to explain it or you okay? Rise over run. Slope is, you are okay, yes? Rise over run. So then basically, quickly I tell you, you have to pick 2 points. I would pick this one because it's easy to find the values, 25 and 5. And I would pick another one, probably somewhere, where is it? Otherwise, I can find it here, right? It's 18 and 0. So basically, rise is, I would say, 25 minus 18 divided by 5 minus 0. So that's basically the story. I think you guys should be fine with that. Okay, guys. Then this one we can calculate. What is it? 8 divided by 5, which is 1.6. Slope is going to be 1.6. Then equation is, what is the equation, guys? We can solve the equation. Y equals, or Y is actually velocity. Velocity is equal, A is 18 plus B is 1.6 times pi times. That's it. Hold on, they have got 1.4. Is it 1.4? 25 take away 18 is 7. I'm sorry. This is not 8, this is 7. Then it's 1.4, correct. 1.4. Right. So then, guys, 1.4 is the slope. Right. Then this is the equation. That's it. Got it? Right. Then you should be fine. Then you have to do a similar thing here, but this will be a little bit complicated. Make sure you have, as I told you, you have equal number of plots on either side of the equation, on the top and on the bottom of the graph. Right. Then you do the same thing, rise over run, and then you can find the. But this one, there is a problem. You can find rise over run. That's not a big issue. But this one, it's a bit hard to find. What is it? Intercept. Why? Is this the intercept? No, why not? Because this is not 0. This is 10, see? That's not 0, yes? So that means this 8 is not the intercept. Not intercept. Then what do we have to do, guys? Then basically, we have to find 2 points in the graph, or even 1 point would work. Then what, I mean, firstly, you have to find this one. Your first step is you have to find the slope, which we denote by B. So you can find it by rise over run. Okay, they have calculated it for us, which is 1. Then what you have to do is get the equation y equals a plus bx. Then get 1 point, probably let's pick this point. At that point, substitute the values. Y is what's the value of y? 12. A, we don't know what we are going to find. B, we have calculated it 1. X is 14. Then you can calculate for A. What is A? A is going to be negative 2. Okay, makes sense? Yeah, see, A is negative 2. Okay, so then that's what you do. What did I do? I firstly found the slope. Having found the slope, I applied the equation. How? I pick 1 point, right? One coordinate. In that coordinate, I substituted the y and x values with the slope. Then what, there is one unknown variable which is a, and we can calculate for it. Okay, guys, any questions? Nope. Very good. Right. Then we are going to do the least squares regression line. Right. Least squares regression line is that we are going to use this one. What do you mean by least squares? Least squares means technically, guys, have I explained you the residual? Residual means this. Residual is how, see, the red line is the graph that we have drawn. So that is giving us kind of an idea when x value is x value for a given number, what is y value? So using this equation, yes, using y equals a plus bx, right? We can, what do? We are trying to uh, 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 forecast, or we are trying to um, uh, anticipate or project, right? Um, what else? Another term for that? You can say forecast or what else? Forecast, mm, or project, anticipate, right? Basically, we are going to what's a better term? Yeah, technically we are going to project or forecast a value, or we are going to get kind of closer value. How much would be the y value when x is for a given value, right? So that is, so y, and at that point it will be a projected or a uh, assumed value, right? Prediction. So basically, we are going to predict, right? So it's a predicted value. So predicted value is on this line, on this red line. But for that, when we have an x value, there can be an actual value for that. And what's the actual value? Actual value is what we have plotted here. So for example, when now see, when x value is 4, y value is also 4 actually. But in this case, it is a different one. So the difference between actual and forecasted or the predicted value is what we call as residual. So basically this space from here to here, that space, so what they have drawn arrow, that's a space. Basically that's a deviation. There is a gap from what we forecasted, what we predicted, and what we have got actual. That is the residual. So basically, I can give you, if you want the formula, actual value, take away predicted or uh, forecasted value. Predicted, right? Prediction. Predicted value, right? Actual take away predicted. That's the residual. So what are we going to do here, guys? We are going to see least squares. Least squares means these residuals we are going to square. Why we square it is, if the actual value is, for example, for this one, residual value will be a negative value. Why? Actual value is lower than the predicted value. So it will be a negative. So to get rid of the negative value, we square it. So that's why we say least square. We are going to minimize this residuals. Okay? Minimize the residual. For example, in the previous question, so where did we do that? Here, previous one, we are saying, look, our predicted value for when student staff ratio, so when it is 16, or we'll take the previous one, that car velocity thing, this one, right? For example, when the time is when the time is mm, here 2, when the time is 2 seconds, what we are predicting is how much? Around 21. But what's the actual one? 22. See, there's a gap, yes? The gap is this. So basically, there's a small gap here. That gap is the residual, right? Actual value is 22, predicted is 21, so that the residual is 1, right? Like that. See, there can be a gap. That gap is what we call as a residual or the deviation. Then, guys, what is it? Basically, that's a residual thing, right? Now we are going to calculate the slope in a different formula as well, without doing the rise over run. Because rise over run we are applying for when the graph is plotted with graph is plotted with uh, I, right? So when we model the when we fitted it using the I, so manually we have done it. Then that's where we use the rise over run. But have a look at this. When we are going to calculate the B using the least squares regression line, we use, what is it? This formula. What formula? B, which is the slope is equal to R, is the um, um, correlation coefficient times by standard deviation of Y variable over standard deviation of X variable. Okay, standard deviation of Y. So R times standard deviation of Y over standard deviation of X. Then also we are going to find the intercept in a different method. What's the intercept method, guys? This one. Intercept, which is A is equal to Y bar. Y bar means what? The mean of Y. Take away B times X bar. X bar means what? Mean of X value, right? So then mean of Y, take away B times, which is the slope, times by X bar. So then that's how we find the intercept. Similarly, guys, if you have been given any other variable, let's say you have been given, you were asked to calculate the R, then you can still calculate for R, given that you have been provided with values for B, standard deviation of Y and X. And still you can find it, yes. Okay, guys, then you want me to show this one or you are okay to calculate? Okay, yeah. Right. Then next one is this one. It's the same thing because you don't have to enter it again this, okay? Why? Because you have already entered. You have still the cash on. Is it gone? Still there? Good. Right. So still 10% works, yes. Right. Now what do we do, guys? Now you go to the same data, spreadsheet, and then Control I, select data statistics, right? Then you have to do the scatter plot this time.
The Y from the income.
Y is no, Y is CO2, income is X.
Yeah, I've got it.
Very good. Right. Then basically you have to get the analyze regression show linear a plus bx, and then you can get the equation.
Yeah, I've got it.
Got it? Good. And then did you get the R value correlation coefficient?
Yeah.
Hmm. Right. Then if you can do that one, you should be fine. And then the other statistics, what we have to do is no, this is for the class fair. Yeah. Basically, then you should be fine. Right. Okay, is that enough? All right.
That's one.
Homework, you can try the questions from 7D up to yeah, up to actually 16 is enough. No. So you have any other questions?